Hello, Patriots. This is Mr. Love, aka the Math Patriot, bringing you guys our very first distance learning lesson from this COVID-19 fiasco. I hope you guys find this as easy to do as in the classroom. And I thought I'd start off with something special. Since you guys don't get to see me every other day like you used to, well, I thought we could start off with my bright and shining face on here. Yes, I've got my gamer set up, so we've got the good quality audio. Hopefully, me tapping on the screen won't be an issue. So let's go ahead and get started on here. And no, I'm not going to make you look at my face the entire time. As you can see, we've got our calculator up because we're going to need it. If you don't have one of these nice fancy smancy calculators, remember you can download those two apps I told you about for you iPhone users. It's Calculate 84. That's going to have a pink logo with a pink icon with a white calculator on top of it. That's currently free. I checked on it this morning. And for all of you Android users, use Wabbit EMU, Wabbit EMU, which is the exact app that I am using right here. So we are going to be needing our calculator quite a bit this unit. So go ahead and get that going. Now let's go ahead and get to it. I'm using a slightly different setup here, so forgive me if this does not go too well. We're going to be starting off with circles and their circumferences. I know you guys have covered circles basically before. I know you guys have covered circumferences before. So nothing majorly new here. Just as always, you're going a little bit deeper. Also, you should have that note set printed off if you are able. If not, these are always available on Google Classroom. And I have copied this, all of the notes I've done from this, into every single period of the notes that are available on Google Classrooms if you click on the resources tab in the classwork section. All right, so let's go ahead and go along here. First off, vocabulary at the very top, a circle, set of all points in a plane equidistant from a point called the center. So what that means is right here, point C is the center of our circle, and then the distance from C to the outside edge of the circle, that is going to be our radius from there to there. Now notice if I rotate this line around everywhere that I go, all these points are equal distance from it. Okay, so let me go ahead and do that. I'll go on our notes for later. Notice that our symbol here is exactly like it looks exactly like what it's describing. It's a circle. So we call this circle C or the circle symbol C. So a few more fill in the blank vocabulary pieces for you. A radius, plural of radius is radii. Segment with endpoints that are at the center and the circle. A chord is one that you may not have seen before. That is a segment with both endpoints on the circle. And then a diameter is a chord that passes through the circle center and is made up of collinear radii. We'll point that out when we get down to our example down here. So let's go ahead and look through our circle and see if we can find a radius or multiple radii. So we're looking for a segment with endpoints that are the center and the circle. So it's got to be here at C. It looks like we've got CD, CE, as well as CF. All three of those are our radii. Now a chord are segments with both endpoints on the circle. So if I look at this, point A is on the circle and point B is on the circle, so AB is a chord. Now, yes, I know it's spelled chord, but we pronounce it chord. The H is completely silent. There is another chord in here, and that is D and E. Even though it passes through the center, we still call it a chord. So there are two there, AB and DE. Yes, all diameters are chords. Now, we only have one diameter depicted on this picture, and that is DE. And we said the whole thing about collinear radii. Well, the collinear radii, here we got CD. So segment CD and segment CE are collinear, forcing those to be a chord that is also a diameter. Also, keeping in mind that a diameter is always going to be exactly twice the distance of the radius. So here, if CF is 8, then I know that all radii in the exact same circle have the exact same distance. So if CF is 8, and then CE is 8, and DC is 8, and I also know that if I was to look at the, sorry, having some technical issues here. If I was to look at the entire distance of the diameter, this is going to be the distance from D to E, the diameter is going to be just the 8 plus the 8 gives me 16. Diameter is always exactly double the radius. All right, example 1. Name the circle and the radii of the circle. So first off, our circle, we're going to use our circle symbol. This is circle R. Now, all of the radii, or all the segments have R in them. So we've got segment RX, segment RA, segment RY, and segment RB. Why is it erasing that? Sorry, I'm writing directly into PowerPoint, and it's always a little bit persnickety. There we go. Remember, if you need to copy these down, I know I'm flying through it, you can always hit the pause button if you need to. Okay, name all of the chords in the circle. All right, first off, let's start with our non-diameter chords. Looks like I'm going to have one up here at AX. So AX is one. Now down here at the bottom, we're going to have YB is another chord. Now our two diameter chords are going to be XY as well as AB. XY and AB. So there's all our chords. Exact same picture. Name all the diameters. Well, it's just a subset of the one earlier. X, Y, as well as YB. If AB equals 18, find AR. Well, AB is this whole distance across the diameter is 18. Looks like AR is the radius. So earlier we had that formula, diameter is equal to 2R. So 18 equals 2R, therefore R equals 9. So my segment AR equals 9. Easy enough. Yes, that's supposed to be an equal sign. Example 5. If RY is 10, find AR and AB. Okay, RY here is 10 inches. So AR here is another radius, so AR is going to have the exact same length as the other radius. Now AB, which is a diameter, is going to be exactly double that, so AB here is going to be double, which is 20 inches. I'm hoping everything so far has been a review from the circle stuff you covered back in middle school. Nothing too difficult as of yet. Example 6. Diameter of X is 22 units. So diameter of circle X is 22. What that means is that from X to Z is half of that. My diameter is 22, then my radius is 11. So from X to Z is 11. Now, the diameter of circle Y is 16 units. So this distance here, oh, that was a really bad brace. This distance here is 16 units. Whoa, I'm sorry. The entire, see, I make mistakes sometimes. The diameter is 16 means my radius is 8. So that is 8. Now, WZ equals 5 units. So this one here is 5. Find XY. Well, let's go ahead and parse through this. If WZ is 5, sorry, if WY is 5 and I can't talk. Let's start over again. We're looking at the red one. If WY is 8 and WZ is 5, that means that I have 3 left over for ZY. Now, XY is the entire distance from X to Y. So here I've got the 11 plus the 3. So XY equals 11 plus 3. That should not say 13. Therefore, XY is equal to 14. Now, The diameter of circle D, circle B, and circle A are 4 inches, 9 inches, and 18 inches respectively. Now remember, this respectively means that the measurements are going to happen in the exact same order that the circles were listed. So here, this 4 inches is going to apply to circle D, 9 inches applies to circle B, and circle A gets 18 inches. So let's go ahead and write all of that in. And those are diameters, which means that circle D with a diameter of 4 gets a radius of 2. Then, I'm going to red now, circle B gets a radius of 9, sorry, a diameter of 9. Therefore, B, I can write it in right here, gets 4.5 from B to A. And then circle A has a diameter of 18, therefore my radius is 9, so AE is 9. Now we're wanting to find the distance from A to C. Well, it seemed like that if circle B has a radius of 4.5, then the distance from D to B must also be 4.5, leaving 2.5 as the remainder in there for CB. So distance from C to B must be 2.5 inches. Okay, that's enough with circumferences and diameter. Let's go ahead and jump in here. I'm sorry, for radius and diameter, let's jump in with circumference. Circumference of a circle is the distance around the circle, traveling the curved path from one spot on the circle all the way back around to the exact same spot. Now, where in the world did it come from? Way back in the day, some people were measuring the distance around a circle, most likely by wrapping a string around it, also measuring the distance across, and they noticed that if you took the circumference and the distance and divided those, you got this nice little ratio, which was pi. Now, pi is another one of our transcendental irrational numbers, means it never is the decimal approximation never ends, never repeats, goes on and on forever. So pi is our 3.141596, and it goes on. That's just as far as I have it memorized. Now, for all practical purposes, in our calculator, we are going to not type in 3.14 like we have done in the past. You're not going to sit there and do this thing. Please do not do that. Our calculator has a pi button. On mine, it's this little blue thing above the caret right here. So the way you access that is by pressing second caret, and you'll notice that it gives us pi, and it knows pi a whole lot more digits than I do. Now, even though it's rounded there, it actually goes farther. And so the most accurate way of doing pi in the calculator is by using the pi button. Please do not press 3.14 and assume that that is going to be accurate enough. So the circumference of our circle, if I was to solve this equation for C, that means I have to multiply both sides by D, and therefore circumference equals pi times diameter. Now, that is not the circumference formula that most are used to seeing. We're used to seeing this diameter replaced with a radius. And since the diameter is just 2 times the radius, then we get our traditional formula of C equals 2 pi r. Now, be careful with this, C equals 2 pi r, because many people want to make that be pi r squared. I'm going to go ahead and write that on here. Pi r squared. Don't get those two mixed up because that is the area. Remember, area has units squared. Perimeter, circumference, is a length, and therefore there are no units squared. Okay, concentric circles. Concentric circles are circles that have the same center. They must be in the same plane. So coplanar circles that have the same center. Here we have two circles named circle A. One of them has a radius of AB, the other has a radius of AC. Now, our two weird words here. Notice what's going on with this circle. We have a circle with a polygon on the inside of it, and every single vertex of the polygon is on the circle. So a polygon is inscribed in a circle if all the vertices lie on the circle. So here polygon LMNP is inscribed in circle K. Now a circle is circumscribed about a polygon if it contains all the vertices of the polygon. So here circle K is circumscribed about polygon MNPL. Now the thing you got to keep in mind there is it's easy to get these words mixed up. Inscribed, it's inside, so the polygon is inscribed inside the triangle or the circle. Okay. Circumscribed means it goes around. By the way, exact same prefix here with things like circumnavigate. When Magellan circumnavigated the globe, went around the outside edge. Okay, so find the circumference of the circle to the nearest hundredth. Now we got to be careful here. I'm going to go ahead and jump to the next one so you can see. Whenever it says exact, we are not rounding. When it gives me the amount to round, I'm going to go ahead and round off, which is why I need my calculator here. Now, you've got two formulas, C equals pi d or C equals 2 pi r. I don't care which one you use. They're virtually interchangeable since radius and diameter are so easy to convert between. But let's just use the one that is already there. If we have a radius, let's use the radius. So here we got C equals 2 times pi times 13. Then we jump to our calculator. 2 times pi times 13, round to the nearest hundredth, I'm going to get circumference equals 81.68 centimeters. And we are done with that problem. Now, for example 9, finding the exact circumference of the circle. Now, let's go ahead and look at our triangle on the inside here. I can see that this is a right angle here at angle K, or at the center. And I also know that these two are congruent because they are both radii. That makes this a 45, 45, 90, a right isosceles triangle. And if we think back to that unit, we knew that that was S, S, and then S root 2. Meaning that the radius of my circle here is going to be 3 because that was 3 root 2, therefore these are 3. So if I'm finding the exact circumference, since circumference equals 2 times pi times r, my circumference is 2 times pi times 3. Now let's go ahead and multiply the 2 times 3, and that is 6 pi. Now, notice that I am not going over here and jumping into my calculator and typing it in. The answer is just 6 pi. I know this looks weird. I know it feels wrong. Just leave it at 6 pi. You really want to turn it into 18 and change, whatever that is. Resist that urge. You've got to start getting used to the idea of having pi in the answer. When you start getting into pre-calculus, you're going to start getting, especially when we start talking about radians. We briefly mentioned radians back in the trigonometry unit, but it's going to be very important for you to get used to seeing answers like this. So 6 pi is our answer. I know it rubs you the wrong way, but get used to it. All right, find the exact circumference of the circle. Here I've got a diameter, which is also the hypotenuse of my triangle. And so I'm going to use a Pythagorean triple. I mean, you can use Pythagorean theorem if you really want to do all that math, but I can see that this is 2 times 3, and this is 2 times 4, meaning that I've got a 3, 4, 5 Pythagorean triple, meaning that this one is going to be 2 times 5, which is 10 centimeters. Now I'm going to use my C equals pi d formula. Since I have the diameter, I'm using the diameter version. So C equals pi times 10, so 10 pi centimeters. And since it says exact, I'm leaving it as 10 pi centimeters, and I am done. Again, I know it rubs you the wrong way. Get over it. All right, example 11. Circle has a circumference of 523.43 centimeters. Find its diameter to the nearest hundredth of a centimeter. Nearest hundredth means I am rounding. I can use my calculator to do that. So I am going to use C equals pi, and wants to find diameter, so pi d. which means I'm going to divide both sides by pi. So d equals c divided by pi. So d equals 523.43 divided by pi. So I just run to my calculator. 523.43 divided by pi. And we get the diameter is 166.61 centimeters. Now let me go ahead and take a minute to show you why we don't use 3.14. If we did 523.43 divided by 3.14, notice, let's try that again. Okay, there it is with pi. 523.43 divided by 3.14. Notice how they are close, but you'll get a different answer. So if I had used this one, I would have gotten 166.70 instead of 166.61. So I know it's really, really close, but we want to make sure we're being as accurate as possible, so use that pi button. All right, very last problem of the lesson. Find the exact circumference of the circle. It says exact, so I'm going to take a pause here to let you try and write that down. See if you can do it on your own. All right, I hope you finished that already. It's going to be a fairly simple problem. C equals pi d. I'm using d because I've got the diameter there already. So C is going to be 11 pi yards. And that is our last example. Now, I know we're doing things a little bit differently here. Notice I'm calling these practice problems as opposed to homework problems. I cut those down quite a bit from what it was on the sheet I gave you at the beginning of the year. And I cut out some of the harder ones. I just want you guys to get some practice in. Make sure that you are doing, or you practice these. Make sure you can do them, and then jump onto Google Classroom and do the quiz that I've got set up there. And that quiz is only about 4 or 5 problems, and it should be fairly easy to do. So let me jump over here. All right. Oh, I'm almost off the screen. All right. Well, I hope y'all enjoyed that. I hope it wasn't too long. Looks like we are at 22 minutes right now. So I'm going to go ahead and cut this off. And the way I end all my broadcasts, especially right now with all this COVID stuff going on, everybody please stay patriotic.